Let's talk about how to compare strings, or objects in general actually. When we were comparing two primitives, for example ints, we would do this with the double equal sign, like this. We would have an int x, we would have an int y, and then we could create a boolean to check whether they were the same by saying x equals y. In this case, it would be true. When we compare objects this way, we're actually not comparing the value, but the reference. So let's walk through this example that applies to objects. We first create a string. As you can see on the slide, we create a string s1 and it holds the value of hi. And we create a second string, using a new keyword also holding the value of y. So we have two strings on our memory. And these strings are having the exact same value, but they're stored in different objects. They have different references, so even though we might want to say that equals should be the same, it will conclude that they're not the same, because they don't have the same reference. The value of the boolean will therefore become false. The string is not a primitive value, but an object, so this is true for strings, but it's actually also true for other objects. If we want to compare objects for equality, we need to use the equals method that you can see on the slide. This will not look at the reference, but at the content of the string. If both strings hold the same text, it will conclude that it's the same as opposed to what the double equal sign did. But then strings are a bit more special than other objects. Since strings are so common in Java, they are stored in a special way for memory optimization. Strings are stored in the string pool. And this has unfortunately nothing to do with the swimming pool. The string pool is a special memory area where strings literals are stored. When you create a string using a string literal, the JVM checks the string pool to see if an identical string already exists. If it does not, the JVM will create a new string object and store it in the string pool, then return a reference to it and store that on the stack. If it does exist already, which is happening in the second case here, where we're creating hi again, the JVM will reuse the existing string object and return a reference to it. In this code, the JVM will create a new string object with the value hi on line 5. It will store it in the string pool. And it will assign the reference to the s1 variable. On line 6, it's going to look at the string pool and will find the string hi there already. It is then going to reuse this object and return the reference to s2. So when we are comparing for a reference here, they will be the same. So if I'm going to say here s1 equals s2, you'll see that these are actually the same due to the string pool mechanism. They are holding the same reference. If I would have created this one with a new keyword, it would actually have created a new object, and then the equal sign would go ahead and produce the result false, because they would not be the same reference, as you can see in the console now. The string pool can be helpful because it allows the JVM to reuse string objects, which can save memory and improve the performance of your program. However, it's important to remember that the string pool only applies to string literals and not to strings created using the new keyword, as I just showed you. So, how should we compare strings if we want to make sure that we're actually comparing the value? Well, we need to use the equals method. If we would want to know whether s1 matches the content of s2 and we don't care about how they're created, we would have to use the equals method. And we do so with the dot equals and then specify the one that we want to compare it to. And if I run this now, you'll see that it's true again, even though I created one of the strings with a new keyword and one of them with literal. So again, use equals when you want to compare, because right now it doesn't matter how the strings are being created. All that matters is whether they have the same value. Strings are a bit special in Java because of the string pool and the immutability. If you want to change a string a lot, many objects get created, and this is actually against the memory optimization mechanism. In this case, it's better to use the string builder. We will see the string builder in the next video.